Hello everyone, welcome back to another informative episode of NE Knowscape. Today we will discuss about why many CBG plants in India struggling after commissioning. India is rapidly expanding its compressed biogas sector as part of its clean energy transition. Through SATAT initiative, that is Sustainable Alternative Towards Affordable Transportation, hundreds of CBG projects have been approved and many plants have already been commissioned. But here is an important question. Does commissioning a CBG plant mean it will continue operating efficiently for years? The answer is no. Several CBG plants across the country are operating below their designed capacity, while some have faced temporary shutdowns due to operational and commercial challenges. According to reports of Petroleum and Natural Gas Regulatory Board and the Center for Science and Environment, the real challenge is not constructing a CBG plant. It is operating it efficiently, sustainably, and profitably over the long term. So what are the reasons behind these challenges? Let's understand them one by one. Firstly, feedstock availability, the foundation of every CBG plant. A CBG plant cannot function without a continuous supply of biomass. Depending on its capacity, a plant may require hundreds of tons of feedstock every day. Even a small reduction in feedstock availability can significantly decrease biogas production. The problem is that feedstock is not always available throughout the year. For example, paddy straw is available mainly after the harvesting season. Press mud is generated only when sugar mills are operating. Cattle dung collection depends on an efficient local collection network. Municipal solid waste often contains plastics, stones, and other contaminants that reduce its suitability for anaerobic digestion. Transporting biomass over long distances also increases operating costs. Without a reliable feedstock supply, maintaining continuous gas production becomes difficult for CBG plants. Secondly, feedstock quality, because quantity alone is not enough. Even if enough biomass is available, its quality plays a critical role. Biogas production depends on factors such as carbon to nitrogen ratio, moisture content, presence of inert materials, organic matter content, biodegradability, etc. For example, food waste generally produces more methane than rice straw because it is easier for microorganisms to degrade. If the incoming biomass contains excessive plastic, sand, or soil, equipment may be damaged, digestion efficiency decreases, and methane production fails. Therefore, proper segregation and pre-treatment are essential before feeding biomass to the digester. Another important challenge inside the CBG plant is biological process instability. One of the most misunderstood aspects of CBG plant is that it is a biological system. Inside the digester, billions of microorganisms convert organic matter into methane. These microorganisms are extremely sensitive to changes in operating conditions. Several factors can disturb the digestion process, such as sudden changes in pH, temperature fluctuations, organic overloading, ammonia toxicity, accumulation of volatile fatty acids, etc. For instance, Introducing a large quantity of poultry waste without proper control can increase ammonia concentration and inhibit methane producing bacteria. Unlike mechanical equipment, microorganisms require time to recover. In severe cases, restoring stable operation may take weeks. One of the most important problem is equipment and technical challenges. Even when biological conditions are ideal, mechanical failures can reduce gas production. Critical equipment includes feed preparation systems, pumps, agitators, hydrogen sulfide removal unit, carbon dioxide upgrading systems, compressors, bottling systems, instrumentation and automation, etc. For example, if the gas upgrading unit stops working, raw biogas continues to be produced, but it cannot be converted into compressed biogas suitable for vehicle fuel. This immediately affects plant's productivity and revenue. Therefore, regular maintenance and timely replacement of critical equipment is essential. Then comes high operating costs. Many plant developers carefully estimate the construction costs but underestimate the operating expenses. Recurring costs include electricity, skilled manpower, water, chemicals, maintenance, spare parts, biomass transportation, etc. If the plant operates below its intended capacity, these costs remain almost unchanged while gas production decreases. As a result, the cost of producing each kilogram of CBG increases significantly, reducing profitability. There is another important problem is digestate management. After anaerobic digestion, the remaining slurry is processed into fermented organic manure or liquid fermented organic manure. This byproduct has the potential to generate additional income. However, many plants face challenges because farmers are not fully aware of its benefits. Distribution networks are underdeveloped, transportation costs are high, market demand varies between regions. Without a reliable market for digestate, an important revenue stream is lost. Skilled manpower is one of the most important components of an industry or a plant. Likewise, operating a CBG plant requires expertise in microbiology, chemical engineering, mechanical systems, instrumentation, and process control. Unfortunately, trained operators are still limited in many regions. Small operational problems can quickly become major failures if they are not identified and corrected in time. Continuous training and capacity building are essential to improve plant performance. And lastly, marketing and gas offtake. See, producing CBG is only part of the value chain. The gas must also be delivered efficiently to customers. Plants may face challenges related to transportation, cascade systems, pipeline connectivity, distribution logistics, coordination with gas marketing agencies. Similarly, digestate also requires an effective distribution system. A technically successful plant may also struggling if its products cannot reach market efficiently. India has tremendous potential to become a global leader in compressed biogas. The country generates enormous quantities of agricultural residues, cattle dung, food waste, and municipal organic waste that can be converted into clean, renewable energy. However, experience from operational plants clearly shows that building a CBG plant is only the first step. Long-term success depends on reliable feedstock supply, stable biological processes, efficient technology, skilled operators, sustainable economics, and strong marketing systems. Understanding these challenges is essential for improving plant performance and accelerating India's bioenergy mission. In our upcoming NE Knowscape videos, we will explore each of these challenges in greater detail, supported by scientific principles, real case studies, and practical solutions. Stay tuned with us. Thank you for watching.